Hello everyone. In this video, we will explore emerging technologies and trends in statistics and data science. These are rapidly evolving fields with new technologies and tools being introduced every day. I will walk you through some of the most notable advancements. Along the way, I will also highlight essential trends and tools that every practitioner should be aware of. Of course, mastering all of them is challenging and not necessary. However, knowing they exist is important to stay prepared for your future projects. First, let's look at some must-know technologies and tools. One of the essentials to know is a programming language. There are three main programming languages: Python, R, Julia. Python and R are the most widely used programming languages. Julia's syntax is similar to Python. One of the biggest selling points for Julia is its speed. Julia is good for numerical computing. If you are a beginner, I recommend you start with Python or R. If you are planning to learn Python, the next immediate question is which Python IDE or integrated development environment to use. The most commonly used one is Jupyter Notebook. It is good for visualization-based projects or small-scale data analysis projects. If you want to document your project using notebook format, Jupyter is easy. Jupyter is not suitable for debugging, that means finding and fixing errors or bugs in a program. Next is VS Code. Visual Studio Code is suitable for developers working on Python applications. PyCharm, the best choice for large-scale projects. It comes with advanced features like refactoring, debugging, and version control. Refactoring means rewriting and improving your code without changing its functionality. This is great for keeping things clean and efficient. Google Colab is a cloud-based platform. This is suitable for deep learning and AI researchers. This is also ideal for students and teams working on shared Python notebooks. For this, you need to visit Google Colab and sign in with a Google account. That means you need internet facility. If you are a beginner, you can start with a Jupyter Notebook. Python data wrangling libraries. Data wrangling, also known as data reprocessing or data munching, is the process of cleaning, transforming, and organizing raw data into a format suitable for analysis. It is a crucial step because real-world data is often messy, incomplete, or inconsistent. Hence, it is essential to know how to do data cleaning with Python. Pandas is the most famous package in Python. Pandas is used for data manipulation and analysis. This is similar to dplyr package in R. NumPy is used for working with arrays. Pandas is more user-friendly, but NumPy is faster than Pandas because of its underlying C implementation. Other packages: Polars, a faster alternative to Pandas for big data. Dask scales Pandas and NumPy for large data sets. PyChanter adds extra cleaning functions to pandas. Next, Python data visualization packages, Matplotlib, a fundamental library for plotting, Seaborn, built on Matplotlib, great for statistical plots. Plotly, this is useful for interactive and web-based visualizations. This package creates declarative visualizations based on Vega Lite. This is useful for mapping and geospatial data analysis. Plot9, this is very similar to ggplot2 package in R. If you are an R user, I recommend you to start with Plot9. Python statistical libraries. The first package, this one is suitable for hypothesis testing and probability distributions based calculations. Stat models, this is useful for regression modeling and time series analysis. SIMPy, this is suitable for symbolic mathematics like calculus, algebra. This writes Python codes like a mathematician. Next, Python machine learning libraries. First one is a very famous package, scikit-learn. This is the core machine learning library for classification, regression, and clustering. Next one is XGBoost and LightGBM. This is suitable for gradient boosting models for structured data. TensorFlow and Keras. These are suitable for deep learning frameworks. PyTorch, preferred for deep learning research. CatBoost, a boosting library that handles categorical data. Next, let's look at some Python web development frameworks and model packages that we can use for model deployment. So that means we can deploy our models for real-world applications. First one is Django, and this is a Python framework that makes it easier to create websites using Python. And these two packages, they are suitable to deploy machine learning models as web services. These are two other packages, Docker, and the other one is Kubernetes. Okay, now let's look at our programming language. Essential libraries. If we are an R user, and then it is essential to know tidyverse style of coding. Tidyverse is a collection of R packages for data science in R. With the packages in tidyverse, you can export data. You can do data wrangling. There are two packages within tidyverse collection, tidyr and dplyr for data wrangling. Then you can further you can do data visualizations with the ggplot. Further, we have packages for reporting, or in other words, reproducible documentation. It is very important to know the tidyverse style of coding. Next package, this is suitable. We can use this package to clean messy data, Janitor. Logridate, this is suitable for time series data wrangling tasks. This simplifies date-time manipulations. Data.table, this is a fast alternative to dplyr and ideal for big data sets. Next, let's see some R data visualization packages. R is excellent for data visualizations. First one is ggplot2. This is similar to plot9 in Python. This is the go-to library for static visualizations. Patchwork, there we can use Patchwork package to combine multiple ggplot graphs. ggthemes, this provides additional themes for ggplot2. Plotly, this is useful for creating interactive graphics. Leaflet, interactive maps for spatial data. Another one is GGE Ridges. This creates rich plots for density visualizations. Next, let's look at some machine learning and modeling packages. First one is Carrot. This provides a unified interface for machine learning models. Tidy models. This is a tidyverse-friendly machine learning framework. Random forest. This implements random forest algorithm. XGBoost. This is for gradient boosting algorithm. LightGBM. This is for faster gradient boosting for structured data. GLMNet. This is for lasso and ridge regression. RPART, suitable for fitting decision trees. Keras, deep learning with TensorFlow backend. Now let's see the packages we have for temporal data analysis or time series data analysis. Tibble. Inside Tidyverse, we have Tibble package, Tibble. When it comes to time series, we have the Tibble package. Here we have additional S. This is Tidyverse approach to handle time series data. Next one is Fable package, modern forecasting package. Rather than using forecast package, I recommend you to use its new version, Fable package by Professor Rob Hyman and his team. Then Profit package, this is Facebook's automated forecasting model. TimeTK. This is useful for visualization and wrangling time series data. Next, let's look at R text mining and natural language processing packages. That means extract insights from textual data. TM is a text mining framework. Tidy text, tidy approach to text analysis. And this package is a fast and scalable NLP package, natural language processing package. And this is for parse tagging and dependency parsing. This package text recipes we can use for NLP processing with tidy models. Next, let's look at some packages that we can use for web scraping. That means extracting data from websites. The first famous package is this one. This is for scraping HTML web pages. Next package interacts with APIs. And the last package can be used with JSON data. Reproducible reporting is an important topic to increase the trustworthiness of your results. Let's look at some packages that we can use for create interactive reports and dashboards. Quarto, this is modern alternative to R Markdown. R Markdown for generating HTML, PDF, and Word reports. KnitR integrates code and text for dynamic documents. Flex Dashboard. You can use Flex Dashboard to create simple dashboards using R Markdown. Shiny for building interactive web applications. And GT, you can use this for creating beautiful tables and reports. If you want to use, if you are looking for a software for spatial data analysis, I recommend you to use R because it has lots of advanced packages. Further, for time series analysis, also I recommend you using R because there are lots of developments within R. These are some of the packages that you can use for spatial data analysis or handling geospatial data. This works with vector data, SP is a classical spatial analysis package. Raster handles raster data. TMAP is suitable for thematic mapping. Terra is an R package that we use for spatial data analysis. GStat is also a package that we can use for spatial data analysis. If you are looking for packages for spatial data modeling or shrinking, I recommend you using SF, SP, and GStat. Now let's see some good to know technologies. With big data, it is important to learn some cloud computing platforms. These are some of the cloud computing platforms: Google Cloud Platform, AWS. These are two other platforms that you can use for cloud computing and big cloud computing. Database and engineering, data engineering, it is essential to know SQL, how to work with SQL databases and NoSQL databases and data warehouses. Now let's see some pre-trained classification models. A pre-trained is a machine learning model that has already been trained or developed on a large data set by someone for a specific task. So what they have done is they have pre-trained a classification model and they have published their model. So instead of starting from scratch, you can use their model and fine tune for your needs. These are some of the some famous classification models. VGG16, it is it's a deep convolution neural network architecture developed by the Visual Geometric Group, VGG, at the University of Oxford. YOLO, this means you only look at once. This is suitable for identifying moving objects. Another pre-trained classification model is a vision transform. There are some libraries where they have some pre-trained models. One is TensorFlow Hub. TensorFlow Hub is a repository of trained machine learning models ready for fine-tuning and deployable anywhere. Next one is Torch Vision models. This is also called PyTorch. This includes ResNet, AlexNet, DenseNet, and many more other models. Now let's look at some trends. First one is explainable AI and interpretable machine learning. Explainable AI is also known as XAI. XAI ensures AI models provide transparent, understandable, and trustworthy predictions. Interpretable machine learning focuses on explaining how models make predictions. This is crucial in medicine, finance, and law. Next one is federated learning and privacy-preserving analytics. Federated learning allows training models without sharing raw data across devices, ensuring privacy. Privacy-preserving analytics include techniques to protect sensitive data. Next one is cheap generative models. These models like GAN, they can be used to generate new data such as images, text, music based on learned patterns. Next one is real-time and streaming data analytics. That means you analyze data as it arrives. Next one is automated machine learning, simply called AutoML. AutoML automates machine learning tasks like feature selection, hyperparameter tuning, and model selection, making machine learning accessible to non-experts. For example, we have Google AutoML, H2O.ai. Those are some of the AutoML algorithms. Next one is causal inference and uplift modeling. Causal inference identifies cause-effects relationships in data. Uplift modeling predicts the incremental impact of an action. For example, who is most likely to respond to a marketing campaign? So these are some of the trends in the field. There are many more. The future of statistics, data science, and AI. These trends highlight a shift towards trustworthy, scalable, and responsible AI.